Today we want to look at hexadecimal number system. So hexadecimal number system, it is a base 16 number system, right? So there will be so many reasons why we need to convert numbers. We need to convert numbers to hexadecimal. So as we discussed earlier, we said computers, they can read binary language. Hence, we demonstrated how to convert from decimal ordinary numbers to binary language. So base 16, now this comes into play so as to help the users, we as users, to easily understand data. For example, you can be asked to compare two 64-bit binary numbers, to compare them to find whether there are any errors, whether they are the same, and so forth. So it will be very difficult for you to compare 64-bit binary numbers. Why? Because there are so many zeros and ones. So just for us to be able to do that perfectly, we need to make use of hexadecimal numbers. So hexadecimal, it uses a table which consists of numbers 0 to 9. Then from numbers 10 to 15, they are replaced by letters of alphabet, which are A up to F. So 10, instead of writing 10, we write A. Instead of writing 11, we write B. Instead of writing 12, it's C. 13 is D. 14 is E. And then 15 is F. So for us to convert from a binary number into hexadecimal, we simply have to consider the number of bits that we have. Maybe if it is an 8-bit binary number, we simply divide by 2, right? We simply divide by 2 because each character in hexadecimal is represented by a 4-bit binary. So if it is an 8-bit, we divide by 2, and then the first part we add the binary units that are switched on, and then on the other part we again add the binary units that are switched on. Then we find the corresponding value. So let us quickly show you, let me show you how to convert binary numbers into hexadecimal. So we have got two types of numbers that we want to look at today. So we have got numbers which are less than 10, right? Or the numbers which are less than 10, and the numbers which are equal to or greater than 10. So all the numbers which are less than 10, if you ask it to convert them to hexadecimal, they don't change. However, I'll simply show you, I'll just show you the working, right? For the purpose of being able to demonstrate. And again, for the numbers which are equal to greater than 10, they will change their values. They will take the forms of either A, B, C, D, E up to F. So let me show you how to convert binary numbers to denary numbers. So the question is saying convert 1001110100001 to hexadecimal. So this is a binary number. We want to convert it to hexadecimal. So like I said, we group this into a group of 4-bit binary numbers. So if you count on the binary number that we are given, it has got 12. It has got 12 bits. So we write the first four. The first four are 1001, right? We demarcate, and then we also have 1101, 1101. We demarcate, and then we have 0001, like this. So what we simply do, remember, in a 4-bit binary number, 4-bit binary units 8, 4, 2, and 1 are used. So we simply write our 2 to the power 0, 2 to the power 1, 2 to the power 2, and 2 to the power 3. So the same applies here, 2 to the power 0, 2 to the power 1, 2 to the power 2, 2 to the power 3. Same applies here, 2 to the power 0, 2 to the power 1, 2 to the power 2, 2 to the power 3, like this. And we add all the binary units that are switched on. So in this scenario, the binary units that are switched on is 8 and 1. So 8 plus 1, it will give us 9. And here the binary units that are switched on are 8, 4, and 1. So 8 plus 4 is 12 plus 1, we get 13. So 8 plus 4 plus 1, we get 13. And here it's only 1. So now 8 plus 1, we said yes, 1, 9, and then 13 and 1. So instead of writing 13, remember we said in hexadecimal, we don't need 2 elements to represent a character. We only need 1 element. So we use this table, this hexadecimal table, this one, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and 15. So all the numbers which are below 10, they don't change. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So 10 will be replaced by A, 11, B, 12, C, 13, G, 14, E, 15, F, like this. So this is the hexadecimal table that we use. So now, instead of writing 30, the answer would be, the answer for 1001110100001 to hexadecimal, it will be 9D1, because 13 is equal to D, so it will be 9D1. So 1001110100001 to hexadecimal would be 9D1. So this is how we convert from hexadecimal, from binary to hexadecimal. So we also want to demonstrate how to convert from decimal ordinary numbers to what? To hexadecimal. Right. So the question says convert 58 to hexadecimal. So when you are converting from decimal ordinary to hexadecimal, what you simply need to do, you need to convert this decimal ordinary number first to binary, then you convert from binary to hexadecimal to make it easy, right? So this is how we do it. Alright, so that's the first method. So 58 to binary, let us convert 58 to binary. So 58 to binary. So 58 is greater than 15, so therefore we use an 8-bit, right? 8-bit binary unit, that's what we use. So our 8-bit binary unit is 128, 64, 32, 16, 8, 4, 2, and 1, right, like this. And then we find, we consider all the units that if added together, they'll give us 58. So 128 is greater than 58, we switch off. 64 is greater than 58, we switch off. 32 is less than 58, we switch on, right? So 32 plus 16, it will give us 48, we switch on. 48 plus 8, it will give us 56, we switch on. 56 plus 4, that will be 60, we switch off. 56 plus 2, 58, we switch on, and then we switch off here. So now we have the binary equivalent for decimal 58. Then we now need to convert this decimal to, we need to convert this binary to what? To hexadecimal. So now we convert 00111010 to hexadecimal. Right. So the method is the same. What we simply have to do, we count how many bits do we have here. In this case, we've got 8 bits. So we divide into equal groups of 4-bit binary numbers. So we simply write 00111010 1, 2, 3, 4. We put our demarcation line here. So now we've got 4-bit binary numbers. They use 4-bit binary units, which are 8, 4, 2, and 1, 8, 4, 2, and 1, like this. And now we consider all the units that are switched on, right? All the units that are switched on, we add them together. On the left side, you've got 2 plus 1, which will give us 3. On the right side, you've got 8 plus 2, which will give us what? 10, right? So our answer, so 58 to hexadecimal would be equals to 3. And remember, we said 10, we don't need 2 elements to represent a character in hexadecimal. So 10 will be replaced by A according to the table that I gave you. So it will be 3A, like this. That will be our answer, 58 to hexadecimal. So this is how we convert from decimal to hexadecimal. from decimal to hexadecimal, it is called decimal ordinary. So in the previous video I demonstrated converting from what? Binary to hexadecimal. So this is how we do it, right? So when you're converting a decimal number into hexadecimal, first of all you need to convert that decimal number into binary. Then after you do that, you simply divide by the binary number that you have into groups of 4-bit binary numbers. Then you need to make use of the 4-bit binary units for you to be able to convert those sets of 4-bit binary numbers into dinar numbers, right? There will be dinar or decimal numbers. So as long as you get a number that is less than 10, you just write it as it is. But when you get a number that is equal to or greater than 10, then you need to replace that number with the letters of alphabet, which are A to F. So that was the process, as simple as it is. There is another, again, second method of converting dinar numbers or decimal numbers into hexadecimal. So if it is a dinar number or a decimal number, you can simply use successive division by 16, since it is base 16. So successive division by 16, and then after you get your answer, you take those remainders, right? You take them from bottom to top, the same way we did when converting dinar or decimal numbers into binary, right? Using successive division by 2. That's the same approach that we use in converting dinar or decimal numbers into hexadecimal by successive division by 16. So that was it for today. Watch out for the next video. Thank you very much.